Hey everyone, welcome back to another session in this IBDP MAI HLSL course. And today we are going to discuss SL 1.6 topic, which is errors estimation, bounds, significant figures, and rounding of the answers related problems. Okay, so one by one, I will discuss the techniques or the concepts behind this, and then we will solve some questions on this as well. Okay. So first thing is that we will learn how to approximate for the decimal places and the number of significant figures. Okay, I'll give you an idea about this also. And upper and lower bounds of the rounded number. How to find the upper bound or the lower bound of a given number. If its units are given, based on that we can answer this. What is the percentage error and how much maximum or minimum percentage error is allowed, that we will also discuss. And then we will see some problems on estimating the values. Okay, we will see whether a result is given to us, whether this result is valid or not, reasonable or not. Okay, so let's start with the significant figures first. Okay, so there are some rules. I'll discuss all the rules one by one. First rule is all the zeros, non-zero digits are always significant figures. Okay, for example, if I give you a number like 748182226, there are 8 digits in total, right? And hence 8 significant figures are there because none of the digit is zero. Okay, so directly I can say all non-zero digits are significant. One more example, if I have in decimals 123.45. So even after decimal, we have some numbers. Don't worry about it. Count the number of non-zero digits. Here we have 5. So it has 5 significant figures. 123.45 have 5 significant figures. Next rule. All zeros between the two non-zero digits are also significant figures. For example, we have 103.05. Here, as you can see, there is a zero between two non-zero, right? And again, there is a zero between two non-zero digits. As many zeros are there, it's not only for one zero, as many zeros are there between two non-zero digits. They are all considered as significant figures. So here 5 significant figures are there. One more example. Like if you have 78000 zeros and then 2. Yes, again I will say there are two non-zero digits at the end of these three zeros, right? So yes, we will have total 6 significant figures including these three zeros. So in these cases, 0 becomes significant. One more. Zeros to the left of an implied decimal point are not significant, or the zeros to the right of the explicit decimals are also significant. Okay, so for example, I'll give you an example. This one, 23,000. In this 23,000, as you can see, for these three zeros, it's not bounded by two non-zero digits, right? So it has only two significant figures like 23. But if I write the same thing as 23000.0, now just because of this decimal thing, right? All these zeros will become significant. So in this case, you will have total 6 significant figures. Can you see that? Writing our answer as this and this. Both are same actually, values are same, but their representation makes different significant figures. Okay. So in this way, you can check whether we have to count those zeros or do not count those zeros in case of zeros at the end. Okay. Okay. Now, to the right of a decimal point, all leading zeros are not significant, whereas all zeros that follows non-zero digits are significant. For example, like if we have 0.0043. So in this, how many significant figures we have? Only two, because we have 0 point something, right? In the previous, for example, here if I have 2.0043. So yes, in this case, we will have how many? Five. Five significant figures are there. 2.0043, because this time zeros between those after the decimal are considered as a significant figures. But in this part, because of this, okay, the next zeros are not considered as significant figures. Okay, 0.0043 have only two significant figures. But if you have 0.043 and few more zeros after that, yes, these zeros will be considered as significant figures. So in this way, you will have five significant figures. Do not count these three. Always remember this. Okay. So if you have 0. As many zeros, do not count them. First non-zero digit appears. Okay. Start from there. All the zeros or non-zero digits after that will be considered as significant figures. Okay. Now, let's discuss few more questions. Here is the first one, and let's find the significant figure in all these. For example, if you have 30020, you can try these questions all by yourself also. You can uh, pause the video and try these questions. Okay. Now, let me start with giving you number of significant figures. So, in this first part, these four are significant figures. Do not consider this because I gave you the reason, right? If they says 30020.0, yes, in that case you will have six significant figures, but this time we don't have that. See the difference? No, so do not count that. For this only four significant figures. Now for the B part. For the B part, yes, this time we will count that. So in this way we have 2 plus 2 plus 2, 6 significant figures. For the C part, it is 0.008. So in this way, in this question, we will not consider those zeros, right? After the decimal before. Okay. So only one significant figure. D part, 1000.0. So because of this decimal, yes, all these zeros will become significant. So in this way, we have total five significant figures. Next one, 1.09, yes, simple 3. Now F part, 7.00101. So in this case, what we will do? Yes, we will consider all the digits, including these, right? So how many significant figures do we have in this part? Okay, let's write it. So we have 7.001, three these and three these, total six digits, six for this. So now 0.02, only one, correct? Only one. And 0.020, because of this 20, we have two significant figures. Okay, so that's the answer for this one. So let me write all the values. 4, 6, 1, 5 and answer. Okay, now after this, let's move to the next question. It says, okay, one more concept, how to round off the answer. Before starting the question, how to round off. See, if you are rounding off a given number of decimal places or significant figures, check for the next digit. If it is 5, 6, 7, 8 or 9, then round up to that. If it is 0, 1, 2, 3, 4, then round to the same or down to that one. For example, if you have 2.7138 or if you have 2.7132 or if you have 2.7130. Okay. So you want to round off this value to the, let's say, three decimal places or four significant figures. Okay. So in that way, you will write it as 2.71. Then this will be the value that you have to check whether we have to round up or not. So 3, check the next digit for that. It's 8, right? It is more than or equal to 5. So round up. So it will become 2.714. In the next one, it will be 2.713 only. Here also it stays the same, 2.713 only. Or if they say 2.7135, then it will become 2.714, because for 5, 6, 7, 8, 9 round up, or for 0, 1, 2, 3, 4 keep it as it is, right, to that number. Now let's discuss these questions also. Here it says write down 0.041792 correct to either two decimal places or two significant figures. You can again pause the video and try these questions. Later you can verify your answer with mine. Okay, so let me start with the first one. What it says. First one is 0.041792. You have to round up, correct up to two decimal places. Two decimal places. So look at the 0.04 only. What's the next digit? 1. Correct? Okay. So because of this 1, okay, you have to round up, correct, to two decimal places. It is 1. So keep it as 0.04 only. Now, two significant figures. For two significant figures, what is that? 0.0, no significant figure till this part. Next, yes, here I have first significant figure. So I have to round up to two significant figures. So I need one more digit. So 1 and next is 7. So check with respect to 7. 7 is more than or equal to 5. So yes, here I will get 2. So that's my answer. Okay. Next. Write 67.0812 degree to the nearest degree. Nearest degree. So 67 point, what's the next? 0. So because of this 0, you can leave your answer at 67 only. But three significant figures. Okay. So in this way, you have to correct your answer up to three significant figures. First significant figure 6, second significant figure 7. Then there is a decimal. I need one more significant figure. So I have to check for one more digit, which is 0. So in order to check corresponding to this 0, I have to check the next one, which is 8 more than or equal to 5, means this will become 1. Now it is three significant figures, right? Next, 8307.59 kilometers. Nearest kilometer. So check for this digit. What is that? 5. So yes, increase by 1. So it will become 8308. Okay. And the next one is, it says correct up to three significant figures. Okay, three significant figures. So 8307. 8307 have four significant figures. But your answer must be a four-digit number, right? So in this case, how can we write our answer so that we get a three significant figure is, check for this 8, then 3. Now this one is 0 and next is 7. So corresponding to that 7, this will become 1. Okay, and next will be 0 only. So 8310 is for three significant figures, because this 0 is not a significant figure. Only three significant figures are there. Next problem. Next one is, the base of Cheops pyramid is a square. Each side measures 230 meters to the nearest meter. Now first part says find the upper and lower bound of the length of one side of the base. Okay. So in order to find the upper bound or lower bound, what you have to do is check for the given units. It's in meter. Okay. So we have 230 meters. So take the 1 meter unit, that's the unit, right? 1 meter, and take the half of that. Add that number to this value or subtract this number to the value to get your upper and the lower bounds respectively. So here meter, 1 meter divided by 2.5 meters. So we can say it's the upper bound. Now for the A part, I can say the upper bound is going to be 230 plus 0.5, half of the unit, okay, which is meter in this case, half meter. Now similarly, the lower bound. In order to find the lower bound, subtract that 230 minus 0.5. So my answers are, the upper bound of this value is going to be 230.5 and the lower bound is 229.5. Okay, these are the values. Now B part says, hence find the interval in which the exact area A in the meter square of the base lies. So in order to calculate the interval in which the area lies, I have to take the lower bound and upper bound respectively, right? Okay. So what can I say? I can say these are the sides. Okay. It says each side. So in order to find the area, of the square, it will be side square. Okay, so for the B part, the exact area will lie between what? This 229.5 squared to 230.5 squared. Okay, so these are the values in the meter squared, obviously. So when I simplify these, I'm getting, okay, let me use my GDC to get this answer. Yes, it gives me 5 2 6 5 2 6 7 0.25 to it is 53130.25 in the meter squared. Okay, so these are the bounds, and hence we got the area interval in which our exact area lies. Okay, our exact area will lie in this interval. Now, C part. It says regulations requires that the dimension of a football pitch. Okay, now we are talking about a football pitch. For the international fixture must be between 110 to 110 meter long. So there is a range for the length. Similarly, there is a range for the width. Width should be between this 64 to 75 and length between 100 to 110 meter. Now it says calculate the smallest value of area A by F, where F is the area of the football pitch and A is the area of this base of pyramid. Right? Here we already got the value of A. Okay, A. Now it says calculate the smallest value. For the smallest value, what do you have to do? Take some A and take some value of F. Remember, in order to get the as smallest as possible value, you need to take the smallest value of area, of the pyramid, and divide it by the maximum value of the area of football pitch. Okay, maximum of that. Why? Because if the denominator is more, right, overall answer is small. Because of that, I'm taking this. Okay, so what's the maximum area, smallest area of the football first? So smallest is this 5 to 670.25 divided by F max. So for the maximum area of the football pitch, I have to take the maximum length and maximum width. They are 110 length times width, 110 times 75. Okay, once I simplify it, yes, I can use my calculator GDC for calculations. After that, round off our answer correct up to three significant figures. In your exam also, you have to write your answer correct up to three significant figures, and in this case I'm getting around 6.38 units. Okay, now the D part. It says hence comment on the minimum number of football pitches that fits into the square base of the pyramid. How many football pitches that fits into that pyramid area? So what can I say? Here I can say the using this relation. It is actually more than 6 times, right? More than 6 times. So 6 is the value that will fit into it. Okay, so here it says comment on the minimum number of football pitches. So the answer is 6 is the minimum number of pitches that can fit into the square base of the pyramid. Okay, that's my answer. Now, let's move to the next problem. What's the next question? It says an angle is 38 degrees. A student estimate the answer as 45 degrees, then find the percentage error in the student's work. In order to find the error, what we have to do is we have to take the estimated value, subtract it from the exact value, okay, divide it by the exact value, okay, take the modulus and multiply it with 100. That's my percentage error. Okay, now in this particular question it says the an angle is 38 degree. A student estimates answer to 45. So yes, there is a gap, there is a difference. Right, difference of what? 7 units in our given value and the sorry, estimated value and then the exact value, right? So here, let's find the percentage error. So in order to do so, I need estimated value minus the exact value, which is 38, divided by 38. Okay, take the modulus. By the way, in this case, it is already positive, times 100. Okay, let's use the GDC to calculate this value. Okay, so for this one, I'm getting 45 minus 38, which is 7, divided by 38 times 100, gives 18.4211. Okay, so 18.4211. I have to write my answer correct up to three significant figures, as I said. So I'm getting for 18.4211, and I can approximate it to three significant figures, which is 18.4%. Okay, now next part says the side of square is 7 centimeter to one significant figures. Okay, side is given. Now find the maximum percentage error if the area is quoted as 49. So this is the quoted area. Okay, now we have to find the maximum percentage error. In order to find the maximum percentage error, I need to find the maximum value of the area, right, which is calculated by taking the upper bound. Okay, so let's find the upper bound. It's in centimeter. You remember I said take the unit and it's half. So half centimeter will be added to it. Okay, so half centimeter means 0.5. So what will be the side now? Upper bound will be 7.5. Okay, centimeters. Now corresponding to that, what's the upper maximum value of the area, right? That will be, it's a square, so 7.5 squared. Okay, let's calculate that. 7.5 squared comes out as 56.25. Okay, so that's the maximum area now. Okay, so what's the exact value? We already have the exact value as this 49, and this is the value 56.25, which is the maximum one. Find the difference between these two. What is the difference between these two? Let's find that, and on the basis of that, we can get our answer. So now the percentage error maximum, I'll say, maximum percentage error will be like this: 56.25 minus 49 divided by this 49, right? Exact. Divided, multiplied by 100. So now let's calculate this value also. So it is 56.25 minus 49 comes out as 7.25 divided by 49 gives, multiplied by 100 also. Okay, so it gives me 14.7959. That much percentage. And you remember I said we have to write our answer correct up to three significant figures. So take the next only 1 4, this point. Third significant figure is this. Check the next one to it, 9, which is more than or equal to 5. So make it 8, round up. So 14.8 is the answer. Okay, now next problem, one more question, which says Jenny calculates the probability of getting 5 heads when flipping a coin 8 times as 2.5. Explain why Jenny's answer cannot be correct. Reason is, see what she is getting as the probability 2.5, but we know the maximum value that you can get for the probability is 1 and the minimum is 0. Probability of any event always lies between 0 to 1. 0 if it is impossible event, 1 if it is sure event, but it can never exceed 1. So here, that's the problem here. So our answer cannot be correct. Okay, so in this way you can also check for reliability of the answer also. Okay, and you have to give the reason, and the reason is probability lies between 0 to 1. Okay, so in this way you can get any other question also. Okay, so in this session, what we have covered so far, let me mark those points. We started with rounding off a number and calculating the number of significant figures, right? And calculating the degree of the accuracy for the answer. Like they says, find up to three significant figures or up to two decimal places and all. Upper bound and lower bounds, estimating the percentage error and the maximum or the minimum percentage error. That's also done. And determine if an answer is reasonable or not. Okay. So that's it for this session. Thank you for watching this. See you in the next part. And if you have any other doubt or any question, feel free to connect with us. Thank you for watching.